Hello everyone, welcome to today's session. Today we are going to discuss the topic called section modulus. Section modulus is related with the moment of inertia. In what way? This is the thing we are going to concentrate in today's session. Let's take section modulus. Generally it is represented by the letter digits. How can we find out and how the section modulus is incorporated and where it is very much useful? If the value of the section modulus is higher, what happens? Section modulus, which will determine the strength of the beam. We already know what is a beam. A beam is a structural member having supports like simply supported beam, cantilever beam, fixed beam. So we have a beam, and what is the strength? How can you measure? It depends on the section modulus. If the value of the section modulus is higher, the strength of the beam will be higher. Okay. Then how can we find out the section modulus? This also depends the cross section. Okay. Because it depends on the moment of inertia. I already told in the previous video. Moment of inertia does not depend on any material or any other pressure, temperature, or any other parameter. It depends only on the cross section. Okay. And section modulus also depends on the cross section. And we have one mathematical expression for section modulus, which is equal to I by y. I by y. Here you know that this is I equal to area moment of inertia. Area moment of inertia. And this y. Y is the maximum distance. This considers the maximum distance from the neutral axis. From the neutral axis. So I put the delta K, that's neutral axis. How can we find it? Okay. And the unit for the section modulus will be equal to beta 4 divided by beta, that's equal to beta q. Will be the unit for section modulus. Let's consider for rectangular section. For rectangular section. Okay. Having depth B and depth B. For this case, what will be the section modulus? Okay. The section modulus is equal to I by y. So there and the expression. You know that let's take about the expressions we will take I x is equal to d by what is the I value. And what is the y value? So y is, I told you this is the maximum distance from the neutral axis. So I, this is called the neutral axis. Okay, this is called neutral axis. Otherwise, if you call this one, okay, originally is also called neutral axis. So the neutral axis from the point, okay, is taken y value. Okay, this is called y from the neutral axis. So y is equal to half of the vertical distance called y by d by 2. So here y is equal to d by 2. Then I told you the neutral axis. So neutral axis is the axis where a body can be, a section can be separated at the separated by 2, exactly by 2. And you just fold it, it comes unfolded together. Okay, so it becomes symmetrical. That axis is called the neutral axis. And neutral axis, what happens in the bending stress? That is the portion. Okay, so at the neutral axis, if you fold it, it will bisect each other. So bending, the bending strain will be equal to 0. Okay, so at the neutral axis, bending strain or bending stress is equal to 0 for any section. Okay, for any section, neutral axis is equal to, so bending stress is equal to 0. Okay. For this case, so this y be equal divided by d by 2. So this is 6. So this finally we get b squared by 6 is the section modulus for the rectangle. Okay. The same way we can have another cross section for a rectangle cross section. For rectangle cross section, how this section modulus will be. Okay. For circle cross section, we take having diameter d. Okay. 5 value equal to 5 d over 4 by 64 and y. So y will be from the value of the middle axis. Same thing, we will take the 5 d over 4 by 64 divided by d by 2. So it will be 5 d by 2. Okay. 5 d by 2 will be the section modulus for a circular cross section. Okay. So that's all about section modulus for today's class. We will see the next another class with the next. Okay. Thank you for watching the video.